a tripod. I might not get to any of your comments, but I'll try to remain engaged with you guys. No cameraman today. Hello, hello. All right, so we're started. I'm not doing any updating of anything right now on stuff, but we'll get around to it. All right, so I was wondering like how we could loop this to maybe power a secondary over here, like turn the trifilar strand into a drive coil using power from this one, but I don't know. All right, we got the DC power supply. Currently we're input at 12.5 volts and 0.3 amps, so 300 milliamps. You can see that the power secondary output is pretty bright. Primary objective was to get the motors to spin in a loop. So primary objective is to get that to spin. Secondary is the light, and the light's pretty freaking bright. So what I mean by that is there's two outputs connected to the SSG Bedini K energy store output. There's two things connected to the output, the motor and the light. And as you can see, both are being powered very well. With only 400, 300, 400 milliamps. That's awesome. The faster that one goes, the faster this one will go. Because, and the light, the SSG light is off. So that's awesome. But without the light being plugged in, the SSG light would be on, most definitely. So you need that secondary output. You can't plug a battery in though, because then you got to start using diodes, other than the ones that are already there. Because you plug a, if I change the output from the light to the battery, immediately this battery will begin to run this pulse motor. And that's no good. It's not what we want. We want this to run this, not this to run this. And this will take over because it has more power than the output of the Bedini. It does. It so will, and it does. And I was like, dang, we almost had it, but no. This, you'll drain this, power that. You put some diodes in here, and then you immediately, it's like you cut your, you only have the top of the sine wave then. And maybe it's doubled up or double looped or something like that. I don't know what it's necessarily called, but it's totally different. There's no negative input, so I mean the negative spike definitely wouldn't be going on, you know. There'd be a lot of things that just wouldn't be happening. And because you're using it for directional purposes, right? But you get two, it's a double whammy. You get the direction, but then you get DC energy out the other side too. So you don't want that. because it doesn't charge the same as just having a direct connection. I mean, we could definitely, I'm starting to make myself curious as to what would happen if we did hook it up that way and try to charge this battery instead of running the light. Yeah, I'm gonna run over here and check this out real quick. Hey, how's it going, everybody? Yeah, that's right, Noah, thank you. I mean, in the attempt to correct the directional error here, you're going to change all the power to a different type of power. And it's like you're already going through a diode, you're going through a double diode here. You got one positive and one negative diode for the output. I guess if you put the two diodes, a positive and a negative diode, you could get the power to go through it directionally, positive and negative, just like it's doing here in the circuit. But I mean, doubling up on diodes is going to reduce your power, without question. And you can do it. I've done it. I've so done it. I've had like 100 diodes, not literally 100, but it felt like 100 diodes hooked up to the pulse motor, and you know, it did reduce its effectiveness. Maybe not its efficiency, but its effectiveness. And yeah, I didn't like it. And that's mainly why I try to avoid using diodes. If I have to, I'll throw one in there, to avoid, you know, stuff not working. But I absolutely love this, because this coil and this coil combined reduced the amp draw by about 400 milliamps. But you gotta have this coil in there. It reduces 400 milliamps off the power needed to drive this motor. So that they're so connected now that it's like they need each other to function, and the better each one functions, the better each one functions. It's awesome. Like the faster this one goes, the faster this one goes. Speaking of speed, I was looking for my tachometer. Oh man, it was right there, and now I don't know where it is. Anyway, this is going about 1500 RPMs, give or take. I don't know about this one. This one's going a lot slower, but it's the faster this one goes. You can see the light is pulsing to the speed of this one, and the light is coming off the. Wow, it's so awesome, and it's working great, and it's only drawing 400 milliamps. That's about where it's supposed to be. But without this coil, it'll draw 800, and without this motor altogether, it'll draw 800, where it's at right now. So I found that very significant, the reduction in amperage, just by using another motor. Not exactly sure why it's doing that though. There's got to be some sort of science behind this. I think it's cool. Yeah, no, I don't know about that. Let me see here. Okay, I think, yeah, there you go, Noah. Had to do that one on the fly. If there's anything we need to fix, we'll fix it later. All right. So I'm gonna explain it from like the power supply to the end of the output in the SSG. We're gonna try to connect the dots like one at a time. We're going power supply, 12.5.4 in to the SSG, which powers the 18 gauge strand. That's timed by the 32 gauge strand. So you got your drive and your trigger. Then you got your resistor, a 460 ohm resistor. You got your transistor, which uses the trigger strand to pulse the motor based on the magnetic, the electricity generated by the magnets through the trigger strand. And then from the circuit, we go to the coil, which is a trifilar coil. And they're kind of I've explained a lot of the coil already, but the trifilar is a 20 gauge strand. It's currently not hooked up, but it's generating about 6 volts of AC electricity that is usable. I don't know. I don't know how else to put it. You know, you could hook it up to this cap bank scrubber thing. This is really just a throughput that changes it from AC to DC, and then it'll store energy that it doesn't spend, kind of thing. Okay. So the cool part about this is it needs 2 outputs. It has to have 2 outputs. I've tried doing it motor alone, and there's not enough energy being spent for this. The light always goes on the SSG. All right. So we put the light in there to absorb the rest of the energy that the motor decides not to use. Every time the motor hits, the light gets brighter. This motor. Every time this motor hits, this gets a burst of speed, and that gets a burst of light. Up to, I believe it could get up to like 1600 RPMs. It's not that fast. It's fast enough though. And then from this whole setup is hooked up in series with the output. So the energy goes out the positive end of the output into this coil, then into this coil, then into the switch, and then into the negative of the output. Whew! I heard something. And then, I mean, this is really, really light. So the fact that it is continuing to spin at such a phenomenal rate without power is awesome to me. It's really awesome. And why it's so awesome is I got this one that weighs like 5 times what that one weighs. This is 100% PLA. It's got 9 of the cubes in it. And that's probably 30% PLA. It's got 3 cubes in it. This one spins like a long time too, and it's got ceramic bearings. You know, it's designed to move. So I'm just thinking, is there any way that makes sense that I can incorporate that trifilar strand into this series loop? And that would kind of close it, pretty much. We'll see. There's another thing I want to check out. I want to get my iron powder, and I want to see the magnetic field on the spin here. So I'm going to do that real quick. All right, I think. Oh, I got an idea. We'll take this, and this is going to be interesting, very interesting. I don't know what the outcome of this action will be, but we're just going to incorporate it in series after the switch, and I don't think it's going to matter where exactly in the circuit it goes because the switch is going to affect it anyway. Okay, so we hook up the beginning of the trifilar with it. I need to get one more connector. All right, and we're going to hook up the negative end of the trifilar to the switch. All right, let's see what happens. A lot more amperage is being drawn, that's for sure. We're at 6.5 volts, 400 milliamps. See, but whatever way I twist this, as soon as I take the power supply out of the equation, it's all going to stop. Because there's nothing on this table that's compensating for that power. And when that power goes away, it's going to stop. What you need is a secondary system that requires a lot less power to run it. And that would be an emergency backup on a ship or something. It would be like secondary system. It's not designed to run the thing. It's not designed to do that. I could see that as being a practical application. For any system with this basic concept, as soon as you take the power supply out or the battery out, and you try to run it on itself, it will not happen unless there's a total compensation for the power that you take away. 100%, or it'll eventually stop. So right now, we got the SSG hooked up and the output is hooked up to this light. And it's hooked up to this coil, and the trifilar coil in this coil, and the switch. That's all on one series circuit connected to the output. And I don't think it's definitely not doing anything beneficial. It's running slower. This one's running slower, and so we're going to unhook that for sure. And that's okay. try other stuff too that probably won't work. Wink, wink. Probably a lot of the stuff that we're going to try isn't going to work. But I like this setup really good. The secondary motor being run by the two coils. It's at 12.6, 400 milliamps. This is probably going between 1300 and 1600 RPMs. It's a primary drive. This one's being run off a homemade switch. This one's being run off an NPN transistor and the SSG from kenergy.store. Really cool circuit, guys. Check it out. Potentiometer is you know, it's good to have one of those too. Yeah, I'm just experimenting. What I'm trying to do maybe is get there to be some kind of loop. With or without the power, but some kind of energy loop. And right now, all this is in an energy loop on the output of the SSG. See, the beginning of this is hooked up to the positive, and the end of this is hooked up to the negative, so it's a big loop. It's not very big, actually. It's kind of a small loop, but it's a very basic loop. Series circuit, energy, we're just using the output as a battery, basically. It's lighting this light pretty bright and running that motor at the same time, so I say that's a win. Let me try something else here. Actually, I'm gonna hook the trifilar strand up to this battery. I'm gonna see if I can't charge the battery with the trifilar strand while running the other motor. And we'll hook up these, I guess. It's our multimeter. You know, I don't know if I'm going to go directly. Yeah, we're not going to do that. This is what we're going to do. We're going to go this yellow one. That's AC1. To the cap bank scrubber. And then we'll go AC2. Right here. All right, too much coffee today. Holy cow. All right. And then yeah, I gotta get one more connector for this. I want to use the large ones because they clip better, and I want the connection to be as solid as it can be. I don't like wires. I'm gonna be honest. I don't like them at all. They really don't allow you to do what I do very well. They they're pretty unforgiving. Oh yeah, we're charging nice and fast. Holy smoke. Well, you notice that our light isn't on anymore. So that energy is going now to the battery. I don't know why it chose to do that, but that's a good choice for it to make, actually. Yeah, it's charging nice and quick. We started at 0.66, we're at 0.69 now. Wow. 0.70. Holy smoke, man, that is going really fast. So I'm gonna go out there and I'm gonna say that having this motor on the output has increased the output and decreased the amount that it takes to run it. But now this one is not going as fast as it was before, and I think it's because there's a lot more like magnetic. There's a lot more stuff going on now. I'm gonna try backing it out a little bit to reduce the lens effect, but have it still in the field enough to not lose effect, really. Yeah, so the answer to my question here is yes, it totally will. The trifilar strand charged the battery. What it does is it takes the, I don't know, it takes the alternate output from the actual output and it's sucking it out of the trifilar strand. That's what I see happening here. It's the same energy. It's just going to a different place. And let's see if I'm right. I'm gonna unclip this. Whew. Not as simple as I thought it was. But we're still at 12.72. So that arc right there didn't cause really any damage. But I don't like it when that happens. Wow, that's awesome though. But you can see how much of a strain generating that quickly puts on the rotor over here, man. It's like barely moving. Now, what was I going to do? I'll leave that part hooked up, and I'm just going to unhook it from the trifilar strand. Yeah, that makes more sense. Try to unscramble these wires a little bit as we go. Lights back on. Nice. And I think you're always going to get more speed with the light. With the light as a load instead of the battery, only going to produce more speed, and it's probably going to produce a little less amperage draw as well. Because that's what it's doing right now. That's bright. That is very bright. I've heard from several people now that these machines can manipulate time. So I don't know. I haven't seen it much myself. I don't really know what I'm looking for. But I can't confirm that either way, yay or nay. And at the same time, I can't confirm whether that's really a big deal or not. You know, it's like, oh boy, people have been doing this since the beginning anyway. You know, I feel like I can do what these things are supposed to do in my head, you know, just by thinking about it. But you know, that's not true. That's just that's a fantasy. That's excitement. That's you know, I don't know. But as to whether or not running a dilation factor on time is there a consequence to doing that? Is having the magnets grip the fabric of time and spin it around a little bit? Is there a consequence to doing that? Is there a consequence to just going one way? And you can go the other way without consequence. What I mean in time is, can you go to the past and the future without consequence? I say no. I say you can't go to the past without a consequence. Because I believe people are like Tesla coils. They have a resonance all their own. Literally, somebody can walk into a room and you will not, and all of a sudden you'll notice that they're there, and there's a reason for that. You know, and that it's because there's a resonation there that you picked up on. They don't have to. They don't have to make any sudden movements, and chances are that you're going to look at each other too. Chances are you're going to glance at each other. Look eye to eye, because there's a resonance going on there. If you take your future, your present resonance, and you stick it into the past where it wasn't before, you know, and that's only if, you know, time, you leave an imprint in time. Or is it all just worthless and meaningless anyway? You know, I don't know. Do you leave an imprint in time, a lasting notion of who you were in the fabric of time? Do you? I don't know. You would like to think that you do, right? But I don't know. I don't have any idea. Is time real? I don't think it matters whether it's real or not. It's here. I mean, try experiencing your life in a kind of not real experience, and you'll understand that really doesn't matter. If you believe it's a thing, man, it's going to be a thing for you. A lot of people do. And I bumped into a lot of people that, you know, say, hey, man, it's not real at all. It's just a fabric figment of the prison that is your mind. All that kind of stuff, too, man. I don't know. I don't know about that. I've heard it, though. It's out there. These things, I don't know, necessarily. I've heard, though, that this one over here Let me get this for you guys. This one right here is more likely to rip a hole in time, space, space-time than the other ones are. And that's because it's the electromagnets that are spinning, and there's an on-off with a spin, and that's something totally different than what's going on here. This is always on. These magnets, these permanent magnets are always on. And that's not going to cut it. Let me see. Yeah, we're going to get it. Cool. All right. I wish I could hold the camera up closer. Maybe I'll zoom in for you guys. But I want to see what the black rotor there, what the spinning magnetic field looks like. All right, I think that's a good shot. That's so cool. That is so neat. All right, let's get some more powder in there. Oh man, I wish I could get the camera up here, dude. Woo! Yeah. Alright, that's not good. There's a little bit too much powder, I guess. Alright, we gotta get it to the other side, because that put a crack in the wall. Don't want the powder going everywhere. Holy shit. Yeah, that made the bearing pop out. Glad I saw that, man. I'm glad I freaking saw that. Holy shit. And I know exactly what happened. Wow, that's a mighty transistor. Holy cow, man. I'm so happy that it's still working. All right. You can see how there's a 0 point in the center, and then there's the interior and the exterior. You can kind of see it. That part right there is 0 point. There's no magnetic energy right there. And that's right on top of it. So yeah, that's pretty awesome. That's a big field too for the cubes, man. They got a nice big field. Just a few flecks fell out. That's all right. The bearing popped out of the bottom. I have a bearing in the top and a bearing in the bottom. One on the bottom popped out, and it started to wobble like really, really bad. Because I mean, if the top one pops out, it'll stay relatively stable. But if the bottom one pops out, it's all over the place. But I fixed it on the fly. It's probably not going to stay fixed though. Maybe a little bit of super glue would help that. Because right now it's just in there. Been running pretty good so far though, but when the powder attracted the magnet, it lifted up. The rotor lifted up, but just on one side, and that was enough to yank the bearing out. It happens. I'm glad I saw it. Like I said, I'm glad I saw it, or it could be worse. I love that thing, man. It's kind of loud, but I don't know if you guys saw that. Yeah, you can see it. Heck yeah, that little Tesla coil was a mean little thing. All right, so basically what I've learned doing this is that this reduces the amp draw on the whole system. Having this coil in the mix reduces the amp draw by 400 milliamps. Okay, so I'm thinking the more wire you have in the output, I don't even know, like, because it's a loop, and then this is like a dump. The light is like everything that isn't being used and that needs to be put somewhere is put in the light, so that it doesn't mess with the circuit. When you hook the trifilar up to the battery and you have the output hooked to the light and the other motor here, the trifilar that's hooked to the battery takes precedence over the light. So automatically, somehow, this circuit decided to dump all that excess energy into the battery instead of the light, which I find pretty interesting considering the light is a short, and that would be the shortest path. The light is literally a short. It goes through the light back into where it came from. And then the battery, I guess, is the same thing, but it goes through a lot more chemical processes in the battery. So maybe something about the battery is attracting the energy to go through the trifilar instead of through the output to the light. And it's really interesting to me because this is designed for it to go, to the output. I mean, it probably would take the trifilar because I don't even know. I'm just happy that it did. Maybe looking into why it's doing that a little bit more would be better. Um, but yeah, I think that's really cool that it does that. I, yeah, I'm just wish I had more to say about that particular phenomenon. Let's see here. I know I don't have to start it first, but I like doing that. There it goes. All right. Now, what was I going to do? Oh, yeah. I think we can do this on the fly, so I'm going to do that. Right now, we are currently that is AC2. And this is AC1. So the frequency on the rotor changed to go. It sounds like it's going slower now, which I think it is. But I love that, man. It switched directly from the light to the battery when I plugged it in. Yes, yes. Sorry about that. All right, how about I take the camera off the tripod, get you guys a close up of what's going on here. Gotta plug it in too. I thought I had done that already. Here we go. Thanks for the likes. Appreciate it. Oh, let me get this out of the way. There we go. Now, it is a mess down here now, but you can see these two clips are hooked to the positive, and those two clips are hooked to the negative end of the. And you got both things, the light and the motor hooked up there, and then the tri-filer is hooked up to the battery, this battery right here. And there's its rate of charge. It was at 70 when I plugged it in, so I don't know. Awesome. Howdy, Yanni. Oh man, so yeah, what I found to be really significant is I added the 20 gauge coil to the secondary motor, and the amp draw went down by 300, 400 milliamps. But that was on the secondary motor. You know, it didn't have anything to do with what was going on in the primary drive, or does it? Does it? That's the question. I think because it's a raw electric, connection that literally when that switch is not connected, it's an open circuit. And that's why you got to have the secondary output. Because when that circuit is open, the neon light will go on for sure. And you don't want the neon light to go on. I used to think you wanted it to go on, but you really don't. You can see the light pop back on. Battery's full, so I'm unplugging it. Awesome. So now that, I believe the rotor that I'm looking at right now will pick up speed tremendously because of the change in load. The battery slows it down, the light will speed it up. And see the switch here, this whole wire right here used to be part of the switch up to this glue glob right here. So this whole thing would flop back and forth. It'd go swinging out to here. Like it was bad news. So I taped it and now it's swinging from right there and it's nice and tight. It's awesome. And all I had to do was put a piece of tape on it. That's great. So when I get my transistors coming in the mail tomorrow, I'm going to hook up my signal generator to the Litz coil here because I've been using it to run the secondary motor and it's running it phenomenally well for what it is and what it does. But when I hook up the signal generator, I'll be able to increase the frequency to up to 250 kilohertz. And it says it's for high frequency, so that should be nah, man. I just put a 100 ohm resistor in the way, dude. I got one pot, and I'm not planning on buying another one for a long time. But we could definitely hook that one up. It's a 25 watt, 1,000 ohm resistor, variable resistor. No, I got one pot, Yanni. And I doubt it will stay at whatever you're mentioning for very long anyway. That's it. It's pretty cool. I haven't had much luck using it though, because it's a thousand ohms and it's just a 3/4 turn. And yeah, you can reduce. I mean, you can get this all the way down to like 12 milliamps instead of 500. No, Yanni, you don't understand. This is it. Wish I could do more, but I'm not buying anything else, really. Hasn't turned out, and I'm poor. I'm just not doing it. If you want to donate, that'd be awesome. If you can't donate money, donate the pot you're suggesting, and that'll be awesome too. I know you. Well, I'm not even gonna get. Yeah, I'm not. I'm not going there, dude. Mm, I don't know, man. I have no idea what you're talking about. And when people try to explain it on the live streams, it just doesn't go anywhere. I don't. You hit me up on the Discord, and we can discuss this further. Thank you all. Really appreciate you coming through. Yeah, it's cool. I mean, like, I'm totally interested in what people are bringing up and everything, but I'm not. I'm not doing that on the live stream because I'm not sitting in front of my computer on a chair. I'm playing with electricity, and maybe I'll, get a different, do a few live streams in a different format where I'm more engaged. When I have my cameraman, my brother, when he's here, man, I can engage a little bit more. He likes to engage. I like to engage, but yeah, I don't know about things that don't involve or like the pot, man. I don't. The only place I know for a pot to go that makes any freaking sense whatsoever is on the trigger coil. And that's the only way I know how to use it. It's like that's the only way I know how to use it, and that's how I was. I don't know, man. I don't. It's really, and I don't even know, man. I hate pots. Fucking hate them. I don't know. They work out really easily for other people, but they don't work out very well for me. I don't know why. Like literally, I try and use them, and they're just it's like probably the 10K ones work a lot better than the one that I got. But I mean, like, there's so many what do you call them, parameters to get the right one that people when they suggest ones to get leave out half the parameters that are necessary to get the right one. So you said 2K, 10 turn. I look up 10 turn pots on Amazon. There's nothing there, dude. Is it called a 10 turn pot? I don't know. I'll have to look again. Oh, yeah, man. He's the one who got me on the pot. He made my new circuits for there to be necessary to use a pot. And I don't appreciate him for that. As a matter of fact, I jerry rigged it so that I could get around that. Pots are expensive, man. Pots are not cheap. I don't know, man. I don't know when the next time I'm going to be able to get any more stuff is. So, right there, that's the one I got. And it's flimsy. It's just, it's not smooth. So, I don't use it. And I mean, my goal, and it doesn't matter how low I get this, it's not going to run without the power. And I know that, and it's cool. But it would be a fun experiment, is to see how low I could get it. Yeah, man. When I talked to him the last time, that's when I bought these circuits right here. Okay, what's your point, man? I don't. Boss, why don't you spread the love then, boss? Yeah, man, share it for sure, man. Absolutely. I'm sitting here telling you that I'm broke and that I can't get it pots that I need. Yes, share the link. I mean, yeah. All right, so which path do I hook this pot up to? All right, I'm gonna hook the pot up and see if I can't get it to function better than it normally does. Yeah, I'm drawing a blank on how to even hook this up right now, actually. So you got the power going in, or going through, I should say. Power going through. I see now. Gonna need one more clip. Well, it's not hard once you know kind of what to do, how to hook it up, but it's just big, it's clumsy right now. I'm sure there are better ones, but and I'm telling you, even if I get it down to like 200 milliamps, it's not enough to make a big difference, really. But yeah, we're gonna try and get that frequency here. All right, so our light output is a lot less. Huh. Let's see if we can. .3 volts, 400 milliamps, 500. Yeah, so about 400 milliamps. And then it goes 500, 500. So 400 is in the middle. But as you can see, it's. Oh, we're charging the battery. Are we charging the battery? I don't think we're charging the battery. No. The light is not going on. So in my mind, the output has been choked with the input being choked. Something's not right here. But the light here is not on. That's 800, 900 milliamps. I like how that's moving. That's moving really good. I'm sure without the pot, though, we could get that speed at a lot less amperage than this. I don't know what it is about this thing. It just doesn't. I'd say that's around, and there's no way to really gauge how many ohms this is. It's either going to be like 350 or it's going to be like 650. That's good. I like that. 500 milliamps. That's awesome. Moving quite a bit here. Yeah, but a 10-turn pot at 2K would be a lot more like refined. And I mean, even if you had like some sort of indicator on your pot as to how many ohms is actually there. But I guess if you're going to leave the pot on there, the ohms, you can send it to my channel, boss. If you have a pot that is connected to your circuit and looks good with your circuit and isn't going to drag your circuit down. And what I mean by that is, look at this now. Not like it's a big deal for me, but who else would put up with this? Who else would put up with that? Like having all those cords connected. I don't know. I think it's okay for me, for sure. We're down to 400 now. So maybe I was a little off. I mean, we were at 400, but I mean, there it is. That is really smooth, though. I'm not gonna lie about it or complain, really. I mean, I don't like pots, but that is a smooth run right there. No, I love what they do and everything. I just don't like using them. Unless they are designed for what I'm using them with. But that's a smooth run, man. Very cool. Well, I mean, some potentiometers, I would really want to, if I was going to use potentiometers, leave the potentiometer in the build and not replace it with a normal transistor or a regular non-variable transistor. Just leave the variable one in there. But they were like, you know, if we can get that link and get, you know, what was it, 5 for 10? God dang, dude, every circuit I have would have a potentiometer in it. But this one costs like $20. Well, I don't remember how much it cost, but it was enough to deter me from buying a bunch of them. And it's really bad because things are going to get really expensive here in the near future, especially for projects like this. I mean, there's like the obscure sites, the more obscure ones, but they're going to run out of they're going to run out of inventory quick. A lot of the ones that I was checking out, have been checking out, are already out of what I'm looking for. So I don't know. Pots might probably a lot different, but like the big reed switches, man, I can't find those anywhere. Yeah, I don't know, bro. It's a pulse motor, man. It's two pulse motors actually. One's running the other one. Actually, all of this is in a loop with the output of the first one, the SSG circuit right here. Got 12 volts, 400 milliamps of input. We're running it on a 1K pot, 25 watts. This is a trifilar coil. Trifilar coil is currently not hooked up. The output of the SSG, like I said, is running this setup in a loop. So it goes in and out. Pretty cool. Like a little hangman's noose right there. Alright, so yeah, here's the reed switches that I was just talking about. Can't find them anywhere. Can't find them. I don't know where to look, but I still can't find them. I don't know, it's about this. It's about pulse motors. It's about how I started from, not knowing anything about DC brushless motors. I've been able to build my own in several different ways. It's about expanding, growing. It's definitely about growth. And it's not about completing or an end game or anything like that. It's not about, because this will never be done. This is always going to be changing. This is always going to change. The next time you see this, it'll be different. Okay, so there is no end game, quote unquote. Even if I get over here, if it exists, I probably hit it once or twice. I don't care. We're just moving on to the next thing. Because that's not the objective. The objective is for me to have fun, for maybe explain to people that don't know a little bit more, and to maybe chat along some lines with people that do know, maybe learn a little bit more myself. But in order for there to be a purpose, like what you guys think a purpose is, this has to end sometimes. It has to be completed at some point for that to even be a thing, But I'd say as for a pulse motor, it's done. I'm not building it, it's built. It's a 1 coil pulse motor. It's got an 18 gauge drive with an SSG circuit. It's got a trifilar coil with a 20 gauge trifilar. It's got a 32 gauge trigger, which is hooked to the SSG. It's got a potentiometer, 25 watt, 100K pot, hooked into its resistor slot on the SSG. We got output going to the light. We got output going to the motor over here. We got this right here. If I hook up the trifilar, we could charge the battery with the trifilar energy. We're not doing that now. We're doing the light. You can't do both of these. This and this will not charge and run at the same time. The battery will charge. The battery is dominant in this circuit. And that's pretty much it, man. It's just running the motor right now and running this light. But if I, let's see here. Plug in this cap bank to the tri-filer. If you notice the light, if you can see the light, now the light's off and the battery is charging. And all I did was clip the tri-filer strand, hook it up. Now, in order to charge the battery, the amperage did not go up at all. So there's not more amp draw, which is cool. And it charges really fast for it not being a primary output, I think. But as I was discussing earlier, I think that the tri-filer output is leaching from the primary output, and it's all going to the battery. Whatever's not being used by the secondary motor now is going to the battery through the tri-filer coil. Even though the light's still hooked up, the battery charge is dominant in the circuit. So all the energy is dumping here instead of going through that oscillation. I can't tell you why though. See, that's the thing. I just learned about it, by seeing it. I didn't read about it in a textbook. I don't know how to explain why this charges instead of the light going on. But, if I just unplug one, the light goes back on. Battery stops charging. Oh, so cool, man. So cool. Oh, I love my little onk here. All right. So I think that's cool. I mean, oh wow, the amp draw actually went down. Now it's fluxing between 300 and 400. And this is right around, I would say, 500. Ohms to get that. Oh, it's hot. The little pot is hot. awesome. Yeah, the pot was warm. Not hot. It's just I can tell that it's been it's been warmed up by induction. It's ceramic, so I don't know. Like it's warm. Yeah. And I found out through using many different size coils, I mean gauge wise and weight wise and everything wise, that every coil responds differently for the most part. Every coil has its own soul. And you gotta learn that. You gotta learn it. You make it yourself, you still gotta learn it. And it's that's why when you make a do-it-yourself guidebook on how to build something, it's an exact measurement of how long that strand of wire is to make that coil, so that you can get it as close to the same every time as possible. Because literally every coil is different. Every coil has its own soul. And every coil will need a different input and give a different output, even if it's not significantly different. That's not the point I'm trying to make, significance. Usually I do try to make that point, though, that it needs to be significant or it doesn't count. Because that very fact that every coil has its own soul. So in order to even make a good scientific judgment on a coil, you need to test it 3 times at least. Whatever you're testing about it, you need to do at least 3 tests the same way to get your scientific method out of the way. You need to use a scientific method when you're gathering data. It's the best 2 out of 3, or you measure it 3 times minimum. Because seriously, man, you get it over unity 1 time and then 2 times it's not, you can't claim over unity then. You can't do it because it doesn't pass the scientific method. And that is something that I learned in school, the scientific method. You gotta when you're testing, you gotta scrutinize. You can't look upon your experiment with biased vision. And me, I'm all for something miraculous to happen. I would jump for joy, but I'm not going to jump for joy before it happens. All right. What? Yeah. All right. Now, what I need, I've heard now that I need a pot to get it to happen. I need to use batteries instead of a power supply to get it to happen. I need to have a cap bank in there somewhere in order to get it to happen. And we're talking about over unity here. We're talking about, and literally, if there's going to be, I don't know, man. I don't understand how that would demonstrate itself in a practical setting, because, yeah, I don't think I've ever, I mean, I've had numbers up to 500 AC volts, 640 AC volts, and have that not be enough to run itself, dude. And that's from magnetism, that's from electricity being generated from the wheel. It has nothing to do with the input. Okay, 640 volts and nothing. Literally. I'm telling you, it's not, it plays tricks on you, kind of. And it's just, you can't get the wheel up to speed without the spark. You can't. And if you take the spark out without having enough energy to compensate for the spark, it'll stop every time. And, you know, I got to start using batteries more often, getting into maybe the idea that, you know, with a battery and such, some of this might be possible. I don't know. I need to get amp readers. If I want to do this at all, I'm missing a lot of stuff that I would just right off the bat need. Like amp readers, analog amp readers. That'd be really good to see what's coming out, what's going in. That's one thing. But you know, I already said I wasn't going to buy pots. I'm not going to buy an analog amp reader. I'm not in the market of buying stuff right now. I'm just not doing it. I don't have any money. That's it. End of story. Maybe that'll change. I gotta make it change though. It's not gonna change on its own. Yeah, this is nice. Really low amp draw. It's at 300 milliamps. It's almost at 13 volts. Hello, Matthew. How's it going? I'm not engaging. Sorry, I engage as often as I can right now, but I'm usually over at the table. I don't have my camera guy, so, or he would definitely engage with you. I just hired a moderator, and he's obviously upset with the position that I gave him, so I don't know. Or maybe he had to go eat dinner or something. Or, you know, I'd be there, but I'm here. All right, I'm gonna get the camera off the tripod one more time. Setup's good. I think it's good. I mean, we're moving along slowly. I'm planning on um, trying to hook this up some way so that there can be a loop, an energy loop somewhere in the system. So when I cut off the power, it will continue to run at least for a little bit. Yes, SSG. This is all about you guys. This is all about you. This is all about you. What do you want to see? And it's, you know, if I got it, I'll hook it up. That's basically how it's going to go. Mm. No, no. Nah, it's about me a little bit. It's about me a little bit, man. Absolutely. Hmm. So I have another cap bank here. I have a. This is actually more or less a power pot. So you put your power in and your motor hooked up to this, and it cuts the voltage. Cheers, mate. Yeah, the regulator. What up from South Africa? I'm sorry though. Really have to warn people about that, especially the names. Yeah, that might be a worldly person, but I don't. That name will not be seen on my channel. No controversial issues, even if through your name. I don't, you know, like if your name is Robert Gunn, I don't like talking about guns, man. It's controversial to me. Nah, right on, bro. Right on, Rage. This stuff is definitely what will be coming out of the zombie apocalypse for sure. It's rudimentary. It's easy to build. You're not getting rotors like this in the zombie apocalypse, though. They're all 3D printed rotors. Rest assured, man. The only power you got in the zombie apocalypse is this until it runs out. Mm. Well, I've gone an extra 40 minutes longer than I normally do. But yeah, man, I'm gonna take it easy. Our final input for running this is right there, 12.8 in between 3 and 400 milliamps. All thanks to our potentiometer. And I mean, even with this thing being as light as it is, it'll spin for a long time without power. So if there was to be anything generated or gained from running it without power, it would do it a lot. So cool. See you next time, Yanni. Thanks, man. I'll look into getting some potentiometers. 10 turns. Been looking for them. I just can't find them. See you later. Pete. Thanks, Pete. You the man, Pete. Love what you're doing, man. I want to get one of those switches that you got because that thing is awesome. Yeah, so that. Same to you, Pete. Appreciate you. All right. I'm working on an axial flux setup, actually. Let me just show you guys that real quick. We gotta have it. So that shaft can fall down on the bottom. But axial flux, 120 degrees, ferrite bricks. And the shaft is hooked to this one, so it'll move with it. That's awesome. And it's moving like smooth as butter. So that's awesome. I can hook a fan to this. Pretty sweet. All right, well, thank you very much, ladies and gentlemen. Peace out. Have a wonderful day. And I will get back to you maybe this evening or later on. All right. Bye now.